Yeah, nobody will make fun. We're all good here. You read the COC, right? The Code of Conduct. So, let's see, here we go. So do I have the? There we go. Okay. All right, we'll get the show on the road. So yeah, so obviously I'm streaming this to Twitch and YouTube, or maybe not obviously, but I am. So anyway, so it'll be recorded for posterity. So anyway, I'm going to go through all this stuff. I'm Paul Baylog, and then Mike Madden, he wasn't able to join us. He's my co-organizer for the St. Louis Go Meetup, since I guess I kind of am alternating, it seems like. I guess last time it was Cube and Cloud Native. This time we're doing St. Louis Go. Yeah, sponsors, GoBridge covers meetup costs for this, facilities from CIC, and the food is thanks to Temporal Tom from Temporal Technologies. So good emos. So next time anybody that's watching this live needs to come up. Oh, we do have some. We have a viewer live on there, and yeah, with so it looks like yeah we've got somebody on YouTube. So yeah, obviously any questions come up from the audience, feel free to throw them in the chat there. So we'll see how this is going to all work. This is all an experiment. So yeah, so anybody that's not here, social distancing or whatnot, we got the channel, we got shortcut links for the YouTube channel, the Twitch stream, and then obviously we kind of hang out on the St. Louis Tech Slack, and Gopher Slack is the more international Slack. But if you haven't had enough Slack workspaces to be in. So anyway, just real quick, happy birthday to Go. Go just turned 13. It's now officially a teenager. So hopefully that doesn't mean it's going to be the irate emo years. We'll see. My kids are already past that. So yeah, we're all good. But yeah, so 13 years. Now I just, I'm going to try to keep an eye out on some of the things that are coming up, but now there's a proposal out for structured logging. We were kind of talking, well, I guess we didn't really talk about logging. It was more error handling. But anyway, so for those Java folks, it's more like a log4j. We'll have you can do, with the standard log, you can do info level, error level, and write it out that way, templatized. So yeah, so that's kind of cool. They're going to add that to the standard library. I mean, I know a lot of people add log-rus. I don't know if that's the log-rus.
Oh,
yeah.
logs are us.
Yeah,
oh,
yeah. So
okay.
I don't know. I don't know if that's how you really pronounce it, but that's the way I do it. Logs are us. So
Now it makes more sense.
missing the.
I figured it was like Logosaurus, like a dinosaur or something.
Maybe. But yeah, so that's anyway. That is going on. This URL will actually get you to the topic on there, and then get all kinds of good details on it. So, but yeah, that would be kind of nice. I mean, I do kind of miss that. And just as a heads up, lab days, just in case folks didn't see that, this is just kind of like I'm gonna be here. I come in here to co-work times when I feel like I need to get out of my house and just kind of see people and just kind of go out for lunch. But anyway, definitely swing by. It doesn't, it's for whatever. Drop by anytime. I know I started at like 3 p.m. and I think I stayed till like 7. And then just swing by if you want to talk about anything in Go or project ideas, always looking for something to do. Birds of a feather, check out a co-working facility. If you want a tour, I'll give you a tour of the place. And then, Fika. So Grafana is kind of based out of Stockholm, and Fika is a Swedish thing. It's basically coffee break, and you take them frequently. You just kind of get together and just have an impromptu coffee break, and usually with a sweet of some sort, pastry or whatever, and just kind of talk about non-work things. But it can be work stuff too. So anyway, just feel free to come out. Otherwise, I get lonely. But no. And I don't know, anybody here know of anybody that's hiring for Go developers specifically? It's probably, I don't know, it's getting popular.
Yeah, Temporal is definitely hiring engineering and
There
some
you
other
go.
roles, and Go, Temporal's written in Go. A lot of the development takes place in Go, and there's a lot of companies as well that use Go. A lot of our customers and users use Go. So
Cool. Yeah, so Temporal, I know Grafana, for my case, it's we're always hiring. So I don't know, I want to say since I joined in like February, when we went from like 300 people to 1,000. Obviously not all developers, but they're constantly hiring. Let's see. But yeah, I don't know. Any questions from the group that's here? Let's see. I don't see anything coming from Twitch or YouTube. All right. And that we are blazing right through. I'm going to hand it over to Tom.
all right.
All right. All right. Let me make sure that you're going to be in. Okay. No, you're good.
Okay.
Everybody should see this setup I've got in here. It's kind of, I was stressing out, having a panic attack because it's like, oh no, my camera's not working. But let's see. All right, so let me switch over. You are now added to the stream. I got you. So you just need to take over the display.
All right. How do I do that?
Oh, you should just have to go into your display preferences.
Okay.
And yeah. And then just, do the add display again. And
Okay.
the flame room is what we're in. So, and your code will be 9979. And then you should be cooking with gas.
Okay, great.
There we are.
All right. So the highly customized title screen, failure is not an option. And today I'm going to talk about durable code execution and how you can achieve that with Temporal. I'll begin by talking about what is Temporal, because it's software that not a lot of people have heard of. It's fairly new, but it has a long history, as you'll see. But what it is, I'll begin with a summary. It's a durable execution system. And you might say, okay, what is a durable execution system? That's a reasonable question because it's a category of software that you probably haven't heard of before. It's pretty unique in this regard. If I were to talk about a relational database or a web server, you can probably name 10 or 15 different instances of that type of software. You probably can't name another durable execution system. So it's, again, pretty unique in this regard. What it does is that it ensures that your application runs correctly and reliably, even in the face of all the adverse conditions that can take place. So servers crash, networks fail, the services that you depend on are not always there when you need them. And having to write code to deal with those sort of problems is one of the challenges that we face. And we faced it 20 years ago. If you think about the sort of problems that you faced 20 years ago, if you've been a developer for that long, maybe you were using a computer that had a single processor and you were only working with one thread and life was really easy. Everything was procedural and just step by step. And then when you moved into multi-core and multi-processor and you had to deal with concurrency and threads, things got more difficult. And as things scaled out from having a monolithic machine where everything you need is right there on the same machine and you're making calls in process, method calls or function calls, and you need to scale out. And then you move, to RPC and then to, eventually you become a distributed systems developer. And maybe you don't realize it, but as you try to scale out, you have all these challenges of the network and partial application and those sort of things. So Temporal is a platform that helps you overcome those things. It takes a lot of the complexity of dealing with that out of your application code, and it deals with it at the platform level so that you can code as if failures didn't even happen, if they weren't even a possibility. The way that it does that is it automatically maintains the state of your application. And if it does encounter a failure, and that could be something as simple as you make a network call that times out and it just has to be repeated, it can do that automatically. And it could be a failure like the entire server crash. Maybe there's a kernel panic on your application server and the server just drops, power outage, it just drops immediately in the middle of the function execution. So you're doing a bunch of steps in your code. Let's take the example of you're trying to transfer money from one account to another. So if you think about Apple Pay or Stripe or Square or Western Union or PayPal or any number of other businesses that are sort of built on a payment transfer model, you take money out of, you debit this account over here and you want to credit this account over here. Well, what happens if it fails after this, but it never gets to this thing? How do you deal with that? It becomes a really complicated problem. If you're dealing with a database, you have database transactions and that helps you recover. But database transactions are not necessarily a solution when you're dealing with a distributed system environment and when you're talking about code execution. And so you can think of Temporal really as analogous to what you get with database transactions. At its core, database transactions are an improvement to the development experience. It's not really offering you something new, it's offering you a better way of doing things. So 50 years ago, or 75 years ago, before database transactions existed, you could, in COBOL or whatever language you may have been using at the time, Fortran 62, what have you, you could have done all the I/O. You could read data from disk, and then you could manage the writes to that data, and you could think about, well, what if we have multiple readers and writers and all that sort of thing, come up with solutions to all those sort of scenarios. But it's taking a lot of complexity and it's putting it on your plate. And when database transactions came along, then people could rely on, hey, I'm just thinking about my business logic here. I want to credit or debit this account and credit this account. You're thinking at a higher level because the database transaction is kind of an abstraction that lets you focus on the business logic rather than how it's actually implemented in the low-level details. So it improves developer productivity. That's the goal here, to improve developer productivity. Developer time is expensive. Developers have a lot of things to worry about, and you've got to make your application correct. That's the bottom line. It's got to work correctly. And so, sure, there's all sorts of adverse conditions. The network is not reliable. The server doesn't have enough memory, and any number of problems, but they're your problems to deal with as a developer. So you have to find a way of solving them. So how do you solve them? Well, we're developers. We solve things by writing code, right? So you begin with a simple solution and you're like, oh, this call failed. Well, let me do a for loop and I'll try retry. And then I'll implement a little delay in here. After the first retry, maybe I'll sleep for a second and then try again, and I'll sleep for 2 seconds, and you implement some sort of back off coefficient delay there, and you wind up, okay, maybe you solve that problem, but what happens if you withdraw money from this account and then the deposit fails and it continuously fails? You tried 500 times and it keeps failing. Well, then you have to deal with a compensating transaction. So let's get the application back to its original state by taking the money that we withdrew from the original account and putting it back in there. So the account balances are not out of order. And so, okay, now you have some sort of try-catch, system where in Go, you wouldn't have a try-catch, I guess, but you have to implement all your logic for maintaining the application state in the face of this failure and keeping things consistent. And it becomes your problem to deal with as a developer. So that's really what Temporal is all about, is helping make developers more productivity, or increase their productivity and make their applications more reliable. So let's look at a little bit of a deeper dive into what Temporal is. Well, first of all, it's open source. And so I want to point out a few things here. It's under the MIT license, and the MIT license is a very liberal license. It gives you a lot of flexibility about how you use it. It doesn't mandate that you give changes back. It doesn't prevent you from using it for commercial use. You can use it for private use, commercial use. You can modify the code. You can distribute that code to other people if you want to. And what it does require you to do is to retain the license and the copyright notice. And so if you look at the copyright notice, and I have just an excerpt here from the Temporal repository on GitHub, you can see that the first attribution that we have is for Temporal Technologies. That's the company that I work for. I'll talk more about Temporal Technologies in a minute, but it's a company that was founded to basically serve the Temporal developer community. But there's also, if you look a little bit lower, there's also this other curious thing, copyright Uber. Well, Uber, what do they have to do with anything? Well, Temporal, even though it's only about 3 years old, it can actually trace its lineage back nearly 20 years. And, here I have a picture of the two founders, Maxime Fative, who's the CEO, and Samar Abbas, who's the CTO. If you go back to 2004, Maxime was a tech lead at Amazon, and he worked on the simple queue service, or SQS. You may have used that before. If you've used AWS, maybe you have used the simple queue service. Well, he's the tech lead. He's creator of it. And then a few years later, Samar joined. He had been at Microsoft, but he joined Amazon, and the two of them worked together. Maxime was the tech lead, and Samar was working on the development side of things to lead and then launch the simple workflow service. So another Amazon service that you may have used. Samar went back to Microsoft a few years later, and he was working on Azure. Specifically, he was the tech lead of the Azure Service Bus. And he created something that ultimately led to what's called Azure Durable Functions now. So if you've used Azure, maybe you're familiar with that. As coincidence or as luck would have it, both of them joined Uber in the engineering department of Uber back in 2015. And they got a chance that most developers are jealous of. They got a chance to sort of make a new version of these things that they've done before. So they were trying to solve the problem of how do you communicate at scale? How do you manage a process at scale and make things more reliable? Well, they had done it in the past at Amazon and at Microsoft. And so then they got another chance to do it again and make improvements to the design of things. And so what they created two things. One, they created a queue service that's kind of a SQS variant called ShareMe. And then they also created this other project called Cadence, both of which were open source, and Uber released them. So they're available to anyone. But Cadence is a system that manages, it uses workflows to manage business processes and to ensure that they're reliable. So if you think about Uber, there's so many things that seem so simple as a user, and as developers, if you've ever had to implement these things, you realize the complexity involved. And so if you think, okay, I press the button on Uber, and then a car shows up, and I get in the car, and then I get it out of the car. Yeah, I tell it where I'm going. I get out of the car, and that's kind of it. There's so much stuff that happens in the background in terms of there's location service, and you've got to figure out what drivers are available and notify them, and one of them has to accept the ride. And you get in the car and you drive around, and it's telling them where to take you. And then if the driver never shows up, you don't want to get charged for that. So then you have to sort of make sure that you don't get charged in that particular case. When you get out of the car, and then you have to get charged, you do get charged for the trip that you took. Optionally, you can add a tip at that point, and or maybe you don't tip, and maybe something happened and you reverse the charge. There's a whole number of things that could go wrong, and so managing all that logic is really, really complicated. And you've probably worked on code bases they seem simple at first, and when you get into the details, all the business logic, all the rules, it becomes really complicated. So that kind of thing happened at Uber. Not only for Uber, but Uber has the rideshare business, but they have Uber Eats, and they have lots of other parts of their business, and they have their own payment services internally, to manage the billing, and they have notification services internally, and there's a lot of stuff going on. So Cadence became really popular at Uber, and it was used by lots of engineers over time who were like, wow, we get to throw away all this code that we wrote to deal with these things ourselves, and we can just build our application on Cadence, and suddenly it becomes more reliable. It takes us less time. It's easier to maintain, and that sort of thing. So Cadence really took off inside of Uber. And even though it was open source and people outside of Uber could use it, the driving force behind it was Uber, and so the priorities were set by what does Uber want to do, and they're employing Max and Samar. So Max and Samar realized at a certain point that in order to serve the needs of users outside of Uber, they need to make a change. They need to make some improvements that weren't necessarily priority for Uber. And so they left, and they decided to fork Uber to create a successor project called Temporal. So Temporal, you can think of as kind of a next generation version of Cadence that makes some improvements over what Cadence did. Cadence is still around, it still exists, and there's still companies using it, but Uber is almost certainly the largest user. And a lot of the people that had been using Cadence before have migrated over to Temporal because they wanted to take advantage of the improvements that have been made to the code base. So Maxime and Samar founded Temporal Technologies to sort of serve the Temporal community, and they got some funding and they hired a bunch of developers to make improvements. So for example, Cadence, it supported Java and Go. Those are the two languages you could develop applications in. And at Temporal, we increased that, so we support not only Java and Go, but we also support TypeScript and PHP, and Python is in beta. It's going to be released before the end of the year. There's already people using it in a very significant way. And then we're working on .NET. There'll be .NET support coming in the future, so it's in the very early stages, and potentially other languages being supported as well. So that's one example. We made improvements to the security of the system. Not to say that Cadence was insecure, but we improved the security capabilities by adding encryption and better support for authentication, authorization, that sort of thing. And we changed the communication mechanism to gRPC, which is very popular, for building serious distributed applications. A lot of advantages of doing that, and so that's another improvement that they made. So you can think of Temporal as a next generation version of Cadence. So in 2022, I joined. I didn't put on here, but that's when I joined Temporal. So there's a milestone.
It's not a milestone.
Yeah, milestone. But we had back, and I wondered. I mean, honestly, when I was deciding about whether to join the company or not, I had not previously heard of Temporal. Like a year ago, well, a year ago I had, but let's say 2 years ago I hadn't heard of Temporal. And so I was like, the technology, as soon as I tried it out, I was like, this is amazing. But is it like going to be a success in the marketplace? Are there really companies that are using this, that depend on it, that see the value of it? Like I see the value of it, but how many other people do? And the answer is a lot. And so we had our first user conference in Seattle. It's called the Replay Conference back in August. And I was there, and there were 300 people. It was sold out, and tons and tons of people, companies giving presentations about what they were early adopters, about what they're doing with Temporal, and so on. We also have a cloud service, and I'll talk more about what that is in a minute, but we've had a long wait list for that because we're slowly rolling out access to people so that we can make improvements before we throw the floodgates open. And so we have a huge wait list for it. And so we've expanded access to it. So a whole lot of people that were on the wait list before are actually using it now. So that's another improvement. So I touched on a minute ago about, some example business processes like, Uber and Uber Eats and that sort of thing. But I want you to think about, processes that you may have had experience with as a consumer. Maybe you've bought tickets for a concert or for a sporting event, and so if you have used Ticketmaster, then, not a great experience from my point of view, but it's the leading one.
Those damn fees.
Yeah, exactly.
Have.
Well, there's a finite number of tickets that are available, and everybody's clamoring to get the same set of tickets. And so they implement like a line or a queue, or you have a limited amount of time to buy the ticket before they go back into general availability. And then you have to get billed for the tickets that you bought, and then they try to upsell certain things, maybe parking or whatever. But the user experience is, if you think about how that's actually implemented, a developer, somebody that's not a developer might say, well, I could write that in a weekend. And then you realize doing this in scale at production is way harder than you would have thought it was, but particularly when you're trying to deal with, people trying to buy Taylor Swift tickets right now. It's like crashing the website. So many people are trying to get them. The way that you would solve this problem if you're selling tickets to, an event that's going to attract 30 people is very different than an event that's going to attract 300,000 people. And so if you buy a ticket online, think about the business process involved there. You have to check the inventory. You have to get the price displayed in the local currency. If you're international business, you have to calculate the tax based on where they are and maybe based on where you are. And if somebody orders it, then you've got to take it out of inventory and you've got to send a notification to the people in the warehouse. They pack it all up in a box and then they, ship it off to you. And then you get a notification about it's arriving. Here's the tracking number. And if it doesn't show up, then you've got to reverse the charges. It's a complicated sort of thing. Booking a trip, same way. If you go to Expedia or something like that, you want to book a flight and a hotel and a rental car. Well, what happens if you book the flight and then you go to select the hotel and all the hotels are sold out in that city. You've got to sort of undo this transaction, or maybe change the dates associated with it. Applying for a mortgage or an auto loan, and in fact, servicing the mortgage or the auto loan. I mean, that's a transaction that's going to run for 5 years. In the case of an auto loan, maybe 6 years, or in the case of a mortgage, 15, 20, 30 years. You're getting the bills. You've got to make sure that that process is reliable, not just for a week, but for decades. Filing an expense report. You've got to make sure that it gets approved, and there's humans in the loop that are looking at the expenses, and they reject it, or they approve it, and then the payment takes place, and they've got to take money out of your account, their account, put it into your account so you get reimbursed. So there's a lot of complexity. And another example, I mentioned the Replay conference before. There was a great talk there by Matt McDowell, who is senior director at Yum Brands, incidentally, previously of St. Louis. He worked for Express Scripts, so some of you may know him. But he gave a presentation at the Replay conference. Yum Brands is using Temporal, and their initial project with it is to improve the reliability of their mobile ordering for Kentucky Fried Chicken. So you bring up the Kentucky Fried Chicken app on your phone and you say, I want, a bucket of chicken, and you order it. And well, there's so much complexity involved. I never thought about what goes into ordering a bucket of chicken, but here, I made a screenshot of the thing from his presentation. Well, you add the chicken to the cart and the side of mashed potatoes and, the drink and the biscuit that you want. You've got to validate that order is, you have all those sort of things that are there. You've got to authorize the payment. You've got to send the order to the actual store. And an interesting thing that I learned from this presentation is that, and I may get this wrong, it's because it was back in August, but I think he said 5% of all the stores don't have internet access at a given time. So just like your home internet connection drops from time to time, and you call Charter or AT&T to complain, well, the same thing happens to the local franchise. Their internet connection drops too. And so it could be that somebody ordered the chicken and it made it to, headquarters, to the data center, but it's not making it to the local store. So you have to retry. And if you retry a certain number of times, and eventually somebody's going to give up, and the order will get canceled. You have to undo maybe some of the stuff that you had before. Anyway, the store will eventually confirm the order. Then you transmit that order. You clear the cart. The store says we're ready. Then you close out the order, and at that point you capture the payment. They come and pick up the chicken, and that sort of thing. So there's really a lot of business logic involved. And I've got down at the bottom the name of, if you want to look on YouTube, Matt McDowell is the guy's name who presented it. Chicken, pizza, and tacos. Oh my! I've got the URL there at the bottom. It's a really fascinating talk. There were a lot of great talks at Replay, but really this one was my favorite, and it was an interesting look into what happens in the production system. It seems so easy to order chicken, and then you realize the complexity involved. Particularly, they have dozens of payment systems that they interact with, and so in different jurisdictions they'll have different tax rates, and the menus differ between where you are in the country. So there's a lot of complexity that I never would have realized. Really fascinating talk. So now I want to move into talking about how does Temporal work? What is it? So it's a tale of two things. Over on the left, we have your application. And the important bit is the part in blue. That's your application code. This is the code that you write that implements your business logic. So if we go back to, the payment processing thing, you're trying to move money out of account A into account B. This is the code that says contact the bank, initiate the withdrawal, contact the other bank, initiate the deposit, send a notification. The code that you would write to do all that, that's the application code that I'm talking about. There are two other parts in a Temporal application now. There's the Temporal client, which is provided by our SDK, and I'll talk more about the SDK in a moment, but it's code that we give you. You import a library basically into your Go code, and you make calls there are certain things that you do in the API that result in communication to the Temporal cluster. The Temporal cluster is what orchestrates all your code. I mentioned before that it automatically manages the state of your application so that it can recover in the event of failure, and this is how it does it. So your application code, as it's executing through the code, at certain points, it's sending information over to the Temporal cluster saying, oh, we're calling this function, and we're passing this input, and we receive this output, and it keeps track of everything that's happened so that it knows if this application fails, if the the application just crashes for whatever reason, you pull the plug on the server or whatever, that it can recover, so it knows exactly where things left off, and it can recover the state of all the variables in your application, like even threads, local variables, all of it. It can reconstitute the state of it, so it picks up exactly where it left off. And that's an important point, because if you have a function that has 10 statements in it, and you want to, it fails in the middle without temporal, all you can do is restart that function. You just start over at the beginning because you've lost all the state. But if you're able to maintain the application state, you don't restart, you recover, where you resume. It picks up where it left off. And so I'll talk more about how that works, but that's the general idea of it. So your application code makes certain API calls that translate into requests from the temporal client to the temporal cluster that says, like, we're executing this with this input, we get this output. It's keeping track of all that stuff. And this thing at the bottom, temporal worker, that's also provided by the SDK. You write a few lines of code to configure it in the same way that you might configure a database connection. I mean, it's a handful of lines of code saying what's the host name of the temporal cluster, what port is it listening on. If you're using security, like where's the key and the certificate and all that kind of stuff. But the worker is what actually executes your code. So I say that temporal is a durable execution system, and that is absolutely true. But an important distinction here is that temporal cluster does not execute your code. It orchestrates the execution of your code. It basically tells your application what to execute and when. And the worker is the thing that actually invokes your function and runs all the code in it. So the important thing here is that your code does not exist on the temporal cluster. They're two separate things. So there's the point I'm making. Temporal cluster does not execute your code. The workers execute your code, and the workers are part of your application. You're probably going to have multiple workers on a given server, an application server. And you're going to have probably multiple servers in a real production environment, so that if one of the servers fails, the other ones continue on. And if you need to scale out, you can add more copies of your application and thus more workers. And so you're gaining throughput as well as availability.
Are the workers one-to-one with your processes?
That's a great question. Yeah. So the question is, just for the people there, since I have the microphone and I don't know how well this is going to pick it up.
It should pick it up. I got one here.
Okay. The question just asked was, is there a one-to-one ratio of the worker to the processes that are running? And the answer is maybe. It depends. Typically there is. It's typical that you would have one worker per process, but you can actually run multiple workers in a process. That's fairly uncommon to do, though. But you would have, we call them a fleet of workers. You would have a whole bunch of worker processes running. So you would just launch your application, launch another copy of your application. Each of those runs in a different process. And if you want to, run a different server, like bare metal or EC2 instance in AWS or whatever, you can run even more of them. You can run as many of them as you need to. Did I answer your question?
So one worker is going to run one copy of your app.
Yeah, exactly. And so you can have multiple copies of the app running, and it's typical. It's typical to be able to do that, so you gain scalability. Because if you have two of them, assuming that you can scale in a linear fashion, if you have two of them, you can do twice as much. You gain twice as much throughput, twice as much power in your application. And if one of those fails, then the other one's still going. So you would, in this case, have a degradation in terms of performance, but the application would keep on going. And so a production application, could have dozens or perhaps even hundreds of workers running. So it's common to run these on multiple services or multiple servers, and those could be physical servers in your data center. They could be virtual machines running in the cloud, whatever. So how do you run this temporal cluster? Oh, I should also mention that the temporal cluster, I've got a couple icons there at the bottom. Actually, I'm going to go back to the temporal cluster refers to the temporal server. That's the thing that I have in this pink box, where you've got a front-end service and some back-end services. It's not really important at this point what they do, but these services in the back-end that help provide the reliability, and they keep track of the application state, and they do the recovery stuff, and they keep track of what workflows have been run in the past and let you see like the executions that took place yesterday or last week or whatever. They handle all that. And they store this information in a database. So not only do you have the temporal software, the server software, but you also have a database. Typically that's going to be Cassandra or Postgres or MySQL. Those are the three that are the most common. You can potentially use other ones. And then if you want to do certain types of queries about executions that have taken place in the past, like you would say, I want to see all the application executions that took place between last Tuesday and last Thursday that ended with a status of failure. If you want to query things in that way, you would use Elasticsearch, and it adds a lot of flexibility. It's not required, but it gives you flexibility to find information otherwise. Okay, so there are two options. Actually, there are multiple options for how you would run a temporal cluster, but we can break them down into two categories. One is self-hosted. The temporal software, as I mentioned before, it's 100% open source, MIT licensed. You can run your own cluster on your own hardware. You could run it in a cloud provider of your choice, AWS or Azure or whatever, as virtual machines. If you're doing it for development, and I'm going to demonstrate how all this works in a little while, and I'm going to use Docker Compose. It's a really convenient way to be able to run temporal on just a laptop for development, but you probably wouldn't use that approach in production. Another option that you could use for development is what's called Temporalite, and that was contributed to the Temporal project by Datadog, who's a user of Temporal. So they developed the ability to run all those processes that I showed before, not the worker processes, but the temporal cluster processes in the database. They wrote basically a special distribution of Temporal that runs everything in a single process. And it's a really convenient way to start. You don't have to have Docker Compose and Docker. You don't have all that complexity. You just have one binary and you just run it. And so it's relatively new, but it's gaining ground quickly. And probably this time next year, I would guess that most people will be using Temporalite rather than Docker Compose for a development sort of environment. Because it's just, you could say brew install Temporal and then boom, you're off to the races without all this other stuff. But if you're running in a serious production environment with a self-hosted cluster, you're probably going to be using Kubernetes. There are other options, but that's typically the most popular. As I said, you can run this in your local data center. You can run it in a cloud provider. Either way is totally fine. A lot of companies don't want to own and manage their own infrastructure, even in the cloud. And so instead of trying to run their own temporal cluster and like plan how big it needs to be and have all the machines there and deploy the software and upgrade it over time and monitor and maintain it, they want to offload that sort of thing in the same way that a lot of companies don't want to have their own data center. They've moved things to the cloud. So we have a cloud service, which is called Temporal Cloud, and that provides effectively access to a temporal cluster that's run by the people who know it best. There's an SLA guarantee. There's 24/7 production support, and it basically frees you from having to do all that administrative, server infrastructure kind of stuff for the temporal cloud portion of things. And so it's a really popular thing. This is the one way that we make money. So I want to be clear, like if you think this is like a bait and switch, I want to say Temporal is 100% open source. It's MIT licensed. It's not one of these sort of open core things, or you could run 5 servers but not 10, or you could only have 5 applications and not 20. No, you can have as many servers as you want. You can run as many applications as you want. You can run it at whatever scale. You can do whatever you want for a self-hosted cluster. It's all up to you. But a lot of companies just don't want to deal with that complexity, and they want to focus on the development side, let other people handle the infrastructure side of things. And that's what Temporal Cloud is all about. It's the basically managed cloud version of Temporal Cluster. So I mentioned Docker Compose before. So that's a popular option for development clusters. And so I've got here a few commands that you could run, 3 commands, assuming that you have Docker and Docker Compose installed on your machine. Here's how you could get a copy of Temporal Server up and running on your machine within a few minutes. And I'm going to demonstrate some temporal development stuff, and I'll be doing it this way. So because I didn't know what the network connection situation was going to be like here, and because we have limited time, I didn't want to actually clone the repository live, but I cloned it earlier. And so I'm going to start Docker Compose, and it'll start everything up within a minute or so, and then I can actually do some development. But this is how you'd set it up on your machine. I also talked earlier about when I showed the application architecture where we had at the top the temporal client, and then at the bottom we have the temporal worker. Those are two parts of the application. The third part is your application code. You've got to write that for yourself. I mean, temporal improves developer productivity, but it doesn't improve it so much.
Doesn't write it for
It
you?
doesn't write it for you.
It's not like Copilot?
Yeah, you need Copilot. That's right. Yeah, but the SDK and the worker are the two parts that are provided by the Temporal Software Development Kit, or SDK.
But does it let you like ignore the error return values and go?
Yeah, I mean, if the compiler or interpreter is okay with it, yeah, anything. So in Temporal, I mentioned earlier, I slipped up and I said this term earlier, workflow, and I realized as soon as I said it, that was a forward reference. But now I'm going to come back and fix that. So the core abstraction in a temporal application is called the workflow. You may have had experience with other workflow sort of systems in the past, particularly like no code or low code. We're going to drag and drop these things and sort of model a business process. Temporal is not that kind of thing. Temporal, Max and Samar, as I explained before, they're engineers, and they still write code, they still get technical, and so Temporal is very much by developers for developers. It is all about developer productivity. It's not trying to be a low code, no code solution. It's not that. The way that you write a workflow, as in contrast to some other systems you may have used in the past, is you write code. And what language?
So it's a framework?
Yeah, it is. It is a framework. I guess that's a way of saying it. Yeah. Yeah. Maybe. It depends on the definition of
It
framework.
sounds like you structure your program around it.
A little bit. I don't know. Hold on to that thought.
Okay.
We can discuss that more later. But I don't want to get ahead of myself. But framework might be too heavy-handed, because frameworks a lot of time they're very opinionated, and they're like, this is the way that you do things, and you must implement this interface, and you must have these methods, and you have to do this, and you've got to use these tools, and you've got to use this library, and you can't use that library, and you can only test things this way. And Temporal is not that. It is, it does. There are a few things that it mandates about your code. Very few. It doesn't for example, mandate like, what do you call your functions? What are they named? It doesn't mandate that. It doesn't say you can only use this one IDE. It doesn't say you can use this library, but not that one. There are a few mandates that it makes, but they're reasonable based on the way that it works. They really are required, but it really tries to stay out of your way for the most part. So maybe framework is a little heavy-handed, but sort of it's a framework. Anyway, so in Temporal, the core abstraction for your application is called a workflow. A workflow is simply a sequence of steps. You're writing like, how do you make a pitcher of coffee? Well, you open up the coffee maker and you put a filter in there and you put the coffee in there and you fill it up with water. Like, you have this sequence of steps that you're trying to accomplish. A temporal workflow is kind of the same thing. I want to move money out of this account into this account. So I connect to the banking service. I call the withdraw method on the banking service for this account. I call the deposit method on this account, or function, depending on what language you're familiar with. Same sort of thing here. So temporal workflows, they're written in a standard programming language. Maybe you've used other systems that you have to try to model your business logic in JSON or XML or something like that. So temporal is not that. You write them in a programming language like Go. You could also do it in Java or Python or PHP or TypeScript or potentially other languages in the future. And it also, one other thing that's different about it is it's not based on a DAG model. So some other systems, all the logic has to be sort of pre-computed before execution begins. So you can't really make changes, as dynamically as things are running. But Temporal is not that way. You can very much have cycles in your workflow, and you can change the flow of things based on conditions that arise, as the thing is running. So it gives you a lot of flexibility. You can use your favorite IDE to develop it, or editor, or whatever you want to use. You can use your favorite libraries to do the unit testing, and whatever techniques you have. You can use GitHub or whatever, GitLab or whatever you want to use to store your to store your source code. It really does not make a bunch of demands about how you write the code. But it's important to understand you write code in a standard programming language, and the code that you write is actually the code that gets executed at runtime. It's not like, oh, we're going to write this code, and now we're going to run it through some sort of preprocessor that turns it into this other model that gets interpreted at runtime. No, it's the worker is literally invoking your function, passing the input that you specified, running each statement one by one. It is sending, information over to the temporal cluster about the current state of the application, but it's really running your code. Okay, so how do you get the SDK? Well, it varies depending on what language you're using, but this is the Go Meetup, or at least partially Go Meetup. So we'll talk about how you do it in Go. How do you install anything in Go? Or how do you, there's Go install and Go get, but you'd say Go get go.temporal.io/SDK, and that's going to fetch the latest version of the SDK. The way that you would do it in Python is a very Pythonic way of doing things. The way you do it in TypeScript, you use npm or yarn or whatever you would do in TypeScript. So it tries to be very natural to whatever language you're using. So the SDK, when you install it, it provides the APIs and the libraries and some tools that you'll use to develop workflows and the worker programs that execute your code. And as I mentioned, we offer SDKs for a bunch of different languages, and I named them before. Another thing that Temporal provides is a command line, in addition to the APIs for contacting the Temporal server and interacting with it. It also provides, you download this separately, by the way. Doing go get does not give you TCTL, but it's a thing that you download separately. But it's a command line interface that lets you interact with a temporal cluster. So if you want to write a shell script to let's run these workflows and let's set a bunch of stuff up, and you want to call it in the middle of the shell script or whatever, you can totally do that. And TCTL is the command that would help you. So it has all sorts of commands for starting a workflow, terminating a workflow, a whole bunch of other things as well, but we'll sort of limit our discussion to that for the moment. So let's look. Oh, it also has, I guess I meant to include this, but I'll show it anyway. I'll demonstrate it. It also provides a really awesome web UI. So you can do things with a command line tool. I'm a Unix junkie, so I love to do things from the command line. But if you want to execute a workflow, you can start it from the command line. And if you want to see what's the status of the workflow, did it fail, did it complete, what output did it produce, you can do that stuff from the command line. But you can also do it from your web browser with a web UI, and you can navigate through here's all the executions that took place, during a certain time frame, and let's look at this particular one. We'll see the input, the output, what time it ran, trace the execution of everything, and I'm going to demonstrate that in a little bit. Okay, so I'm going to begin by showing you, I'm going to sort of ease you into workflow development by showing something that's not even a workflow at all. It's just an existing Go function. I'm going to turn it into a workflow. It's all in the slides, though. I don't want to waste your time by trying to write this code. I can write the code because I did, in fact, write it all. But I don't want to write it in the moment because it would take me, longer. So I'm just going to go through this very basic example, really quickly with the slides, and then I'll dive into the terminal and we'll run some more exciting workflows. This is the world's first workflow. What do you do in any workflow? Any introduction to anything? Hello world, right? So we've got a function, greet someone. It takes a string as input. It returns a string as output. And what does it return? Hello, and whatever name you pass in. So presumably you pass in world there and say hello world. So this is just a Go function. It's not a temporal workflow, right? But it's straightforward, the business logic that we have. So if you wrote that, you've got to have some way of executing it, right? So you write a separate program, one with a main method and a main function within, main package, and a main function within that main package. And then you would maybe take some input from the command line. You would invoke that function that you just saw before, pass the input in, get the output out, display that to the standard output. There we go. So we've got the business logic. Now we've got a way of invoking the business logic, executing it. And so that's it. So how would we turn something like that into a workflow definition? With Temporal SDK in Go, you create a workflow by just writing a Go function. There's no funny business. It doesn't make you implement some particular interface or name something a certain way. You just write whatever function you want. That function in temporal technology or terminology is called a workflow definition. It doesn't require you to name it any particular thing.
Does it have to start with a capital letter?
It does, yeah, that's true. It does. That's a good point. Yeah,
It's got to be public.
I think it does have to
That's
be an
funny.
exported function. Yeah, so at least, and I'm not sure I've actually seen it documented anywhere that it has to be a exported function, but every example I've ever seen.
Probably would work.
Yeah.
But
Yeah.
that's the language.
Yeah. So there's 3 steps for turning a Go function like the one that I just showed you before into a workflow definition. The first thing is you import the workflow package from the SDK, and I've labeled that with a 1 here. So we just have an import statement. Number 2, we have to put in an input parameter. So whatever input parameter we had before, we've got to insert one sort of before that, and it takes a workflow context. You've got context that are used within Go. This is a special one that keeps track of workflow stuff. And that's got to be the first input parameter. And then the only other change you have to make is whatever return value it may have had, maybe it didn't return anything, but if it did return something, or whether or not it did, you've got to also return an error because there's a possibility that something could fail. I mean, Temporal is about handling failure, but at some point you may have an unrecoverable failure. I feel like, Jessica, you're asking me?
So the Go question. Here you've imported a library, but not like, you haven't used it, have you?
It's the workflow context. So I would not be able to have this as
there
the
it
first
is.
parameter
Okay.
unless I had that.
All right, cool. That was behind your head.
Okay. I should probably move off to the side.
It's fine.
Okay. All right. So I mentioned before that a worker executes your code. So the worker is the thing that's actually going to execute those lines of code that I just showed you. And so you've got to initialize, configure the worker, and then start it. A worker runs in its own process, and it's going to execute all these lines of code. And each workflow that gets run, it's going to be responsible for executing, so on. As I said before, you may have lots of different workers. You may have a whole fleet of them running across a bunch of different machines. But here's the code. Those are just simply copies of the same thing. So I've got a main function here. I import some stuff up above. But the first thing that we do, I've labeled this with a 1, is we've got to configure the temporal client. I talked about the client before. That's the part of the code that contacts the temporal server and lets it know what we're doing. So we just create that with the client.dial function call. And we can pass in some options here. It's using the default options. What options would be there? Well, if you're trying to contact a temporal server that's not running on localhost, as I'm doing in a development environment, you'd specify the host name, the port number. And if it was a secure setup, you'd have a key file, a certificate, that kind of stuff. But this is the simple case of running locally in Docker Compose. The next thing that we have to do is we have to specify the name of a task queue on the temporal cluster. And that's important to understand how Temporal works. The way that it manages the communication between the worker and the temporal cluster is the temporal cluster maintains a task queue. And it actually maintains lots of different task queues, but for this particular application, there's just a task queue. And the worker will look in the task queue to see if there's any tasks. And the temporal cluster will say, oh, I see you want to run this workflow. Well, I'm going to put a workflow task in the queue. And the worker will say, oh, I see a workflow task. It'll pick it up, and then it'll know, oh, I need to execute this greet someone function that I showed before. So it'll execute it. And then when it's done, it'll communicate back to the temporal cluster, okay, I'm done with that task. The task is now complete. The temporal cluster will say, oh, okay, thank you. And it'll write an event to its execution history. So this is how it's keeping track of the state. All right, we also have to, number 3, so these task queues, number 2, the task queue, it's just a string, it could be whatever you want it. There's very few limitations. We were wondering about this internally, like, it's not documented, like what are the constraints? It has to be UTF-8. You can use emojis, but you probably shouldn't. It could be up to 255 characters. There's some corner cases where it could be longer than that, but you have a lot of flexibility in how you name that. But they're dynamically created, so you call it whatever you want. Creating tasks seems like a reasonable one to use for a function that's called, a workflow that's called greet someone. Then we have number 3 there. We have to register the function that the worker is going to run. We could have a lot of different workflows, a lot of different applications, and not every worker, you don't want every worker running every workflow. If you have a bunch of different applications running, you may want to say, well, we want these 30 workers to be working on this application and these 20 workers to be working on this other application. So you register the ones that you want it to process. So this worker knows how to run the greet someone workflow. It doesn't know how to run some other workflow that could be running on the same system.
Could it have more than one?
Yes, it can have more than one. So you could have it register, 5 or 10 or 20 or whatever number of workflows you wanted to handle. But
So this initialization turns your app into a temporal worker.
yeah, exactly. Yep. So you would include this in your, the code that you deploy, and then you would launch this, and you'd say go run, whatever the name of the Go file is, or you compile it and execute that, and it would run this code. And then we get down to the last thing, which is that w.run. There, we're launching the temporal. Make sure my head's out of the way. But number 4 there. This is what actually launches the worker process or the worker program. So what happens when it hits this line is that begins the pulling. So the worker will start pulling that task queue. And it's not like it pulls it every 10 seconds or something. It's a long pull. It opens up a continuous connection, and it's just constantly checking. And whenever a task comes up, if the worker has spare capacity to do some processing, it'll say, okay, I can accept that task. And let's say the worker crashes because the server gets rebooted or whatever causes the process to crash. That's okay, because the temporal cluster will realize that after a certain timeout, hey, I didn't hear anything back from the worker. It must be dead.
Will pick it up.
So it'll put the task back in there, and then some other worker will pick up the task and begin working on it. So it automatically handles the failure of that particular worker. So it pulls the task queue looking for work to perform. Now, so is it clear what I've said so far? Any questions about
He said if the cluster doesn't hear back from the worker, it'll be like, oh no, it's gone.
Yeah.
Where's the part where the worker gets to pick up in the middle of where it left off?
Yeah, so if the worker crashes and then the worker comes back online later, if no other worker has picked up that task, then the worker, let's say, and I'll demonstrate this in a little while because I only have one worker running on my machine. I could have multiple, but I just have one for this example. I will kill the worker, and then there will be no progress, and things will just be sort of in a stuck state. And then I'll start the worker back up again, and it'll pick up right where it left off. Because the worker knows, it's keeping track of, it knows what it's done. It's caching information. And so it knows where to pick up where it left off.
Probably premature question, but I guess your code, so inside of your worker code, are you setting save points? You say, okay, save at this waypoint, I'm past this.
Yeah, you might think, okay, so how is it keeping track of application state? Is there this manual checkpointing operation? The answer is no. And the real answer is no, but. So no, it is not. So if I go back to this workflow code that I showed a second ago, there's no manual. I mean, it's a one-line thing.
Right.
Yeah,
So that one, it's either done or it's
picking
not.
up
Yeah.
in the middle of that.
Fair enough. But even if this was 50 lines of code, there's no manual checkpointing of state. Now, I talked a minute ago about the event history. So as the worker picks up tasks from the temporal cluster's task queue, it works on those tasks. Then it communicates, hey, I'm done with this task. Well, the picking up of the task and the communicating that it's done, those are documented for all eternity, not all eternity, but for some defined retention period, typically less than 30 days. But for some retention period there, that is documented as the workflow execution event history. And gosh, I just lost my train of thought. What was the question again?
Sometimes
It was about the checkpoint. Yeah.
Oh, the checkpoint. Yeah. Okay. So the workflow event history. So you can imagine at the scale of Uber or some of the other companies that are using Temporal, they are dealing with tens of thousands of workflows and millions of workflow executions every day. And, they're dealing.
And maybe it had to call 6 services to find out what
Exactly.
language to
Yeah,
bring
yeah.
in and
Yeah, there you
how
go.
many explanation points
Exactly.
to use.
So your workflow execution event history might be, I'm sorry, I think I said that Uber is using Temporal. As far as I know, that's not correct. Uber, I think, is probably still using Cadence, but whether it's Cadence or Temporal, it works the same way in this regard. And there's certainly other companies using Temporal at a similar scale, if not larger. But anyway, your event history can grow very large. If you have tons and tons and tons of workflows and tons of workflow executions and lots of things happening within those workflows, every one of those events, and it's keeping track of the input and the output to the workflow. So it's going to get really big. This can cause your database, which is where all this ultimately gets saved to like grow in size. And as database grows in size,
It's expensive.
yeah, it gets expensive and the performance may suffer. And so you want to guard against that. So Temporal has some limits in place. Like it'll start warning you if your event history gets, when you get to 10,000 events, it'll start warning you like, hey, it's starting to get pretty big. And at 50,000, if you haven't dealt with it by then, it will terminate. It'll say, this is the end, pal. So there is a feature built into Temporal, which is called Continue as New. Basically, you can run a workflow, and if your event history starts to get really large, you can just say, okay, we're going to continue this as a new workflow. It's really kind of the same thing, but you can think of it as like an alias or something for the workflow. So like, we're going to continue running this, but it begins with a whole new event history, and so it avoids these limits. So that is, in a sense, manual checkpointing, but it's a kind of a special case, and only when you're getting very large event histories would you do this. But it's certainly not required. Okay. Now, I said before that Temporal doesn't really get all up in your grill about how you do things. Like it's not really trying to define how you write your code, but there are a few things that you can't do. And the one cardinal rule of your workflow code, I'll go back to the workflow code here. The workflow code must be deterministic. And for all this to work, for the event history and the way that it works, it has to be deterministic. And so the simple definition for that is, given a certain input, it has to produce the same result every time that you run it. So if you think about adding two numbers together, addition, that's deterministic.
Yeah.
But if you're dealing with random numbers, or you're trying to query a database from within your workflow, or you're dealing with sort of the outside world, or anything that's failure prone or whatever, you know.
So we couldn't call out to another service and say, what, for this person, what language should we
It's a great observation. So the answer, you can't do it from within your workflow, but wait, you can do it. So I'm going to introduce another concept here. The workflow must be deterministic, but there's this other thing, which is called an activity. And an activity is used to encapsulate code that has side effects, or that's non-deterministic, or that's failure prone. So if you need to query a database, or you need to call out to a microservice, or you need to deal with random numbers or whatever, you could do those things safely within an activity. So what is an activity? Well, it's much like a workflow, it's just a Go function. It doesn't require you to name things in a particular way.
But its result is going to get saved.
Its result is going to get saved. That's exactly it. So when the activity gets executed, then let's say that you have a workflow that's going to run 3 activities. Maybe it's going to like ask the user, hey, what's your preferred language? And then the next thing is it's going to say, okay, what's your name? And then it's going to call out to some translation service. And instead of saying, hello, Tom, it's going to say, hola, Tom. And it's going to greet me in Spanish, or it's going to say, hello, Tom, and it'll greet me in German, whatever. So it's calling after these 3 activities. So if it executes the first activity and that execution is successful, it just it stores the result. And that way, if this fails, it doesn't have to like make that call again. It just replaces the execution with a stored result, and then it picks up where it left off. If the next one, let's say it fails because it's trying to contact a service that's offline, this activity will be automatically retried. So if it's trying to contact this translation service, the translation service is down, it's just going to keep retrying and retrying and retrying. By default, the retry policy, it'll try in perpetuity. It starts off, I believe, with 1 second, then there's a back off coefficient. So it'll be 2 seconds, 4, 8, 16, 32, and so on, until it gets to a max interval, which is 100 seconds, I believe. And at 100 seconds, that's sort of the max. It'll just keep retrying for 100 seconds.
At some point, you don't want the chicken anymore.
That's a great observation. Yeah, exactly. At some point, you don't want the chicken anymore. That's right. So you can customize the default behavior with what's called a retry policy. And you could say like, oh, we're only going to retry 5 times, or we're going to retry, but we'll retry every 30 seconds for up to 10 minutes or whatever, and then we'll stop. Or there's certain errors that we'll retry and certain errors that we won't retry. You have a lot of flexibility in specifying the error handling. But the important thing is you're not writing like thousands of lines of code to deal with all these corner cases. You're basically specifying a policy in like 5 lines of code about, you're just configuring like, what do I want the back off coefficient to be? And there are behind the scenes tens of thousands of lines of code that are proven in production at really big companies that deal with all this in a demonstrably correct way. So you don't have to write all that for yourself. And by gosh, is it difficult? Like, go look at the temporal source code sometime. Like I have written stuff in the past for like my own retry policies and so forth. And I'm like, I'm so clever. I wrote all this stuff. And then when I got to temporal and I started learning the code, I'm like, I wasn't as clever as I thought because I was just lucky that it worked. But anyway, so activity definitions, the activity function, it's just a go function. There's no naming convention. It doesn't have to be in the same source file as your workflow definition. It can be if you want it to be. You have a lot of flexibility there. And unlike a workflow, it actually doesn't require you to specify the first parameter. I said before, you had to have workflow context as your first parameter in a workflow function. Here, there's no such requirement. However, it's recommended that you make context.context the first parameter. And if you do this, then you get certain benefits later on. Like if you want activity heartbeating, that's a feature in Temporal where if you've got a long-running activity, let's say you have an activity that's going to run for 6 days or something, you don't want to like wait for 7 days and then find out like it never returned a result. You want it to be sending a heartbeat to the temporal cluster every 10 seconds or whatever. And if it goes for a certain period of time without getting a heartbeat, then you can say, the server must have crashed, and we'll start this over. We'll put the task back in the queue, and another worker will pick it up. So,
Where it left off, so it doesn't have to do that first 3 days again?
yes. Yeah. Well, first 3 days. It doesn't think in terms of time. It just thinks in terms of what code have I already run.
But you said it was like it took 10 days to execute.
Yeah, right. So if you had, let's say you're doing media processing, you're trying to like transcode some video file that's enormous or something, and it takes a long time, then
or you're working with a mainframe.
Yeah, you're working with a mainframe. Exactly. Okay, so just like a workflow, activities have to be registered with a worker. The way that you do it is quite similar. Here I have register workflow. You saw that before. We also have register activity. So this gives us a lot of control over our workers. We can say, well, this worker handles these activities, but not those. That could be important if you, going back to the media encoding example, maybe you have really expensive licenses for some library and you only have them on certain machines or whatever, then this is a way to control like where things run. And to use an activity within your workflow, here, let's say that we are outsourcing our translation, our greeting service. So we're going to do it in Spanish, and we don't want to have to write the code to do that ourselves. So we translate. We call out to some microservice that does the translation. Up here, we specify some options for our activity. There's a start to close timeout, which is basically, a little bit beyond how long we think that activity is going to take. So if we think the translation is going to take 3 seconds, we might set the timeout here to be 5 seconds, so that if we don't hear back, that we know that this thing is going to time out and get the workflow test put back in the queue. And here we just define a variable that's going to receive the output of the activity that we're going to call. Here we specify the name of the activity, that's the name of the function, the input, and then that's it. That's right there. This returns a future, so we don't have to like sit around and wait on things. It is fairly common though to chain that to the get call on that future, so that now we're blocking. Obviously, we can't get the result until the workflow vector, until the activity execution is done. But whenever that execution is complete, then it's going to assign the result of the activity, Greek and Spanish, to this Spanish greeting variable, and
So
then you
you
just print that out.
wrapped the execution of any function. It can be any function.
Yep.
But you wrap its execution so that you find out and record what it returns.
Yeah, exactly. So did I have a, so here I've got my greet in Spanish, so it's going to call out to some microservice, and it's going to pass in, a value, and then I'm going to, create a URL that's got the parameter in there, and I'm going to make a get call to that microservice, and then I'm going to read the body, and then I'm going to check for errors because it's go, and check. And then I turn that into a string, and I check the status code and all that sort of thing, and then I return the translation. So there's I've encapsulated this, network, this HTTP client call in this function, and that is the thing that's getting executed there. So instead of just directly calling it, I'm saying schedule the execution of this thing and then return me the value when it's done. Make sense? Okay, so let's get to the code. Is this visible to everybody? Okay. So I said before there's the Docker Compose repository. So I'm just going to say Docker Compose up. I've already cloned this. Where are you here? Activity monitor. So it's starting, Postgres and the temporal services and Elasticsearch and all that kind of stuff. And before long, it is all up and running. And I mentioned the web UI before. If you've got a local instance to Docker Compose, that'll be available at port 8080. So I just go to port 8080 and there's the temporal web UI. I already have a workflow. I guess, when did I run that? Yesterday. My first workflow. I'm going to go ahead and terminate that. That shouldn't have been there. Okay. So now switch back to my terminal window and let's look at the first workflow that I showed you before is greeting.go here. So this is the code that you saw before. We import the workflow package. We have turned this function into a temporal workflow. That's all there is to it. And then we've also got the worker. So, and by the way, this is code that I wrote for a training class. So that's why you see all the stuff about exercises in Temporal 101. So here we've got the main function, and we are creating a client, and we specify the name of the task queue, greeting tasks, blah, blah, blah. And then down here on line 22 is, or rather line 20 is where we register the workflow. And on line 22, that is where we begin the polling. And so at that point, it just is contacting the temporal server. So I'm going to go run. Boom. So I'm running the worker, but nothing's actually going to happen because I haven't actually started the workflow itself. So the worker may execute over its lifetime, tens, hundreds, thousands of workflows. So those are two separate things. There's the running of the worker, which is capable of executing the workflow, but then there's the, hey, I want to run this workflow with a given set of input. But the reverse can also be true. It could be that you have a workflow, like a mortgage processing workflow, where it's going to take 30 years to complete. And your worker is probably not going to be running for 30 years because, the machine it's on is going to get rebooted and upgraded and replaced and all that sort of thing. And so the workflow can last longer than the worker in some cases. But they don't, the point I want to make is the lifetime of the worker and the workflow differ. So, start a new terminal window here. And I can never remember offhand all the complete syntax of the tctl command, but I'll show the tctl command here to run the workflow.
In real life, like not demo land, but production, how do workflows get started?
Well, they could get started through tctl, just like I'm doing here, but they could also get started through code. So the temporal SDK, you saw the client API and the workflow API and so on. The client API, just like there was a method execute activity, there's also a method called, or a function called execute workflow. And so you could have your own application code that calls that. So if you had a mobile app or a web app or whatever, when somebody clicks a button, then you may react to that by saying, execute this workflow. And then boom, it kicks off, the booking of the tickets or the.
So workflows, and that would be a case of a workflow being started from outside of a workflow.
Yeah, I mean, workflows would be started from outside of the workflow. But I mean, the workflow, it'd be the workflow would be started. Yeah, I mean, just some other part of your application or an entirely different application could start the workflow.
Do you also start workflows from workflows?
You can, yeah, there's what are called child workflows. So you can have a workflow that kicks off some other workflow. So if you think about, the expense reporting thing, you could think about an expense report as composition because you have different like sections. There's the submit and then the approval, and there's some sort of cycle there, and then you have the reimbursement, and you could have.
So if you do that, does your top level expense report workflow remain open until everything it kicked off completes?
Typically, yeah. There's flexibility, there's different policies you can set up.
Is there a limitation to nesting workflow calls?
Not that I'm aware of. I haven't seen one.
But that
Okay.
makes your workflow database like really important.
Yeah, and in fact, yeah, your choice of workflow database is important, and you can use MySQL and you can use PostgreSQL. PostgreSQL is generally thought to scale better than MySQL, at least for these particular cases. Cassandra is what people running Temporal in production in a very serious way tend to use. It just tends to give better performance, but a lot of organizations don't have experience with administration of Cassandra.
Yeah.
So like if you've got a bunch of really experienced, really good Postgres DBAs on staff, that's probably the best one to run in your particular case, because even though Cassandra theoretically scales better, organizationally it's maybe not the right choice. But all things being equal, I mean, if Cassandra is probably the best choice in terms of scalability. But that is often the limitation of a temporal deployment is the database, because it gets too big, because people will try to send too much input into a workflow. Like for example, go back to the media processing example. You don't want to let's say you've got a bunch of image files and you're converting them from TIFF, which is a really big format, to JPEG or something, which is a compressed format. You don't want to actually pass in all the binary data, for the image itself. What you probably want to do is pass the URL of where to download that stuff. So within your workflow, or rather within your activity code, that's part of your workflow, it would go fetch that and it would do all the processing so that
But then you still have to remember what that activity returned, which would be the whole file, right?
Well, it'd probably return the URL of where it placed the file once it was done. But in this way, the input that you're passing in is just a string, like where to find this thing, as opposed to 6 gigs of binary data, because it is keeping track of the input and output.
So it's legit to say, I guarantee that this URL will hold still.
I mean, that's up to you in terms of how did you design your application, but you could definitely.
I mean, it can be deterministic, if you're using content addressable storage, for instance.
Yeah.
You can be pretty confident that this URL goes to this piece of data.
Yep, and that'd be the right way to do it in that case.
Okay.
I mean, so to be clear, because you said
generically wrapping network calls with eBPF or something to be this is what was returned.
Yeah.
These bytes.
Since you said
many packets.
Since you said deterministic, I just want to point out, you still can't make the network call directly in your workflow. It has to be an activity, but the URL itself will be stable. It's the URL's not going to change, and it's going to continue to point to the same thing later on. The URL is stable, may be a better word there, just because of the rule about determinism. You get what I'm saying? You can't do the actual media processing inside your workflow directly because you're doing I/O stuff.
Okay, so you're putting the processing in the activity too.
Exactly. Yeah.
Oh, all right.
And then that way, if it fails, it can get automatically retried.
Okay, but then when you talk about being able to jump back to where you left off with your same variables and everything, is that for workflows but not for activities?
The workflow, the state of the workflow is completely recreated to where it was before failure.
Workflow,
But
not
if
the
it
activity.
fails in the middle of an activity, the activity you can think of as either it passed, it completed, or it did not. And if it did not complete, then it
It would only
restart
be
it.
started from the beginning,
Exactly.
whereas your workflow can pick up in the middle.
That's right.
And that's because it's preferentially transparent, it's functional in the sense of not having side effects, not being dependent on I/O. But if the processing of this video file took a long time, you still have to start it from the beginning.
Yeah, that's right.
So-
That's right.
Okay.
So, an important thing to mention too is because the activity is restarted from the beginning. If you have, let's say you wanted to put in your activity. Let's take the case of the booking travel. Let's try to book the flight and the hotel and the rental car, and then send somebody a notification and charge them. You want to say those are all. We're making these network calls, so they've got to be encapsulated in activity. Let's just put all that stuff in one activity. That would be a bad idea to do, because if it fails, then they all get started over again. And the first three things may have succeeded, but the fourth one failed, and now you're repeating these steps. So you want to make your activities generally as granular as possible, so that
Preferably item potent.
and exactly, temporal requires that your workflow is deterministic. And if you try to sneak, you're like, oh, I'm going to put these, calls in here, you're probably going to get busted. Like temporal can determine whether you're, depending on how things execute and how far along it gets and whether they get executed again. But there is an error in temporal, and people hit it all the time, and non-deterministic error. It will say your error is non-deterministic. And if you look at the temporal Slack channel, the community Slack channel, there's people that are new to temporal that are like, I got this error and I don't know why. And we have to explain, well, your workflow has to be deterministic. So temporal requires that your workflow is deterministic. It can't actually require that your activity is idempotent, but it is very strongly recommended. And so what that means, what does idempotency mean in terms of, there's a definition of it, which is basically like repeated invocations should not alter the state of the system beyond the initial invocation. That's more or less the definition of idempotent. But what does it actually mean in terms of your application? I mean, can you make a repeated call? It depends on your specific application. There's no general rule. So Dominic, my colleague, who presented at Strangely here in St. Louis back in September, fantastic presentation, available online, so I recommend checking that out. But we were talking about this one time, and he said, you could have, and this is maybe a contrived case, but let's say you have a monotonically increasing counter. Every invocation it's increasing it by 1. And so is it idempotent if you, call this, if you make multiple calls to this thing, the value is 5, and you call it 10 times in a row, and now the value is 15. Does it matter? I mean, it could be that all you care about is that the number it returns now is greater than the number that it returned before. You don't particularly care about the absolute value. You just care about the property of, that it's a greater number than it was before. But on the other hand, if you're dealing with bank transactions, and you want to debit this account and deposit into this account, you certainly don't want to put those two things in the same activity, such that if it fails, now you've debited this thing 5 times and you failed to deposit, into here.
Or even putting the debit by itself in an activity, it's still only idempotent if you pass in a transaction ID and the downstream system says, oh yeah, I already executed that one and drops it on the floor.
Exactly. Yeah, so that is something that idempotence is strongly recommended for activities, but it's really up to the application developer to determine how you should, what it means and how you should implement that within their own application. Okay, so I showed you the code for the workflow. I'm going to start it with TCTL. Boom. Now I just run it. So the TCTL workflow start, I've specified the workflow type, which is the reference to the function. The task queue, greeting tasks, that matches what's in my worker. If this value doesn't match what's in the worker, then they're going to be 2 different task queues. There's the temporal server is going to be putting things in whatever I specified here, and the worker would be checking a different one. So it's important that that matches what I had before. I give it a workflow ID, which is a unique value. There can only be one workflow with a given workflow ID open at a given time. Temporal guarantees that. And so if you're dealing with let's say you have a workflow you're gonna pay an invoice or something, you don't want to have 5 of those running with the same invoice ID at the same time. So this is a way to guard against that kind of stuff. And then you specify your input. This is in JSON format, so that's why I have the weird quoting there. You can also save that input to a file if you have something really complicated, like, big structure, and you can say input file. Anyway, it reflects back to me the workflow ID that I specified, and it gives me a unique run ID, which uniquely identifies this particular execution. What it does not do, though, is it doesn't actually show me what happened. Well, I mean, do we want to wait for 30 years while the mortgage process? The workflow could run for years or decades. So the workflow start command doesn't hang around and wait for the result. There is, on the other hand, this TCTL workflow show, and actually I just abbreviate. There's some abbreviations like WF and workflow show, and then I specify the workflow ID, and then boom. It's telling me the history of this. So the workflow execution started up here. It had the input of Tom. It tells me what the timeouts were, what worker was running it, how many attempts there were. Then it scheduled the task, which means the temporal server put the task in the queue for the workflow. The worker picked it up. The worker completed it. Each one of those things has a timestamp. And then I can see that the entire workflow, because there's only one function, there were no activities, the entire thing completed, and it produced the result, hello, Tom. So I can look at exactly what happened. And if something went wrong, I can see right there, like what failed, which is really nice to have that visibility. So I talked before about the temporal web UI, and here we have the same thing. So we can see that this particular one is completed. I had one that I terminated before, in case you missed it. I apparently ran one a couple days ago.
Why do you reuse the ID?
Well, you can reuse the ID, but it can't be, you can't have two of them running at the same time, two of them open in the open state. So this one is terminated before I ran this one.
Oh, does it show a version history of that workflow ID? So if you had different, like in this case, you recreated a new workflow with that same workflow ID. Does it show the difference?
It only showed the completed one?
Well, so up here where it says workflow ID, I could imagine that I had 50 different workflows running. I could filter up here by typing in my first workflow, and up here. Weird.
Yeah, because I mean, I just kind of curious because like way back in a past life, I used to work with FileNet BPM stuff, and then I know that was always one of the things, and that was one of those drag and drop. Non-techies can do this. They drag and drop little bubbles and stuff.
Yeah.
So
And those you were always able to, you were able to change the workflow. It's like, oh, processes change, so you change your thing and then you can republish it. That's why I was just kind of curious if it's similar to that, if it has a history.
Well, it's tracing not the history of the workflow definition, the code. It's
right.
Showing you the history of the execution.
No. I mean, but that's why I was just kind of curious if you can drill into a workflow ID and see that, oh, this is, the past executions were version, 0.0.1. Now they're 0.0.2.
Yeah, Temporal does have support for versioning. So if you make an incompatible change to your workflow, then you can use versions.
Okay.
It's basically a label that you say, like, this is a new version and it's not compatible with the previous one. So it does have support for that. But it let me reuse the workflow ID. I said before they had to be unique. They do have to be unique, but they have to be unique at the same time.
Yeah.
You can actually set a more restrictive policy. This is called a workflow ID reuse policy. And you could say, not only so by default, it's the least restrictive one, saying you can't have the same workflow ID open at the same time that some other one is open. But you could also say, I not only will not allow them to be open at the same time, I won't allow another workflow ID to be reused ever. Or you could have an exception that's like, it can be reused, but only if the previous one failed. In that case, like, I only want one with a given workflow ID who has ever succeeded ever.
That makes sense.
And you can see the values that are given.
Yeah, so that's what I was going to show. So this is a table listing all the workflow executions. Well, I just have two. the one I terminated earlier and the one that I just ran.
Yeah.
So I can see from this screen, like, hey, this is the one that completed. I can see the start and end time. And cool feature here is that I can see it in UTC. And then I'm like, okay, is it daylight savings time? What time is it in England right now? I don't know. And so you can change it to local. And so it changes it to CST. And we can say, oh, that's the one that just ran a few minutes ago. And then I can also change it to relative. And it'll say like 6 minutes ago, 10 minutes ago. Real handy way to do that. Anyway, whenever you click the row here, it doesn't matter whether we click where it says type or workflow ID, they both point to the same place. And that's the detail page for this particular workflow. So we can see that there were 5 history events, and the table shows them down below. There was one worker running. There are no pending activities, like this thing completed and it's not like waiting on something. While something's running, you can actually see a stack trace in real time. And so that's handy. Queries, we'll not get into that for now, but there's the run ID that we saw before, so we can compare that to what we saw in the command line. We can see how long it took to run. The task queue, number of state transitions refers to like what's happening in here. And then inputs and results is what you asked about. So I can see right there, here's the input to my workflow, Tom. Here's the result, hello, Tom. And then if I scroll down, I can see that same stuff that you saw in the command line before, although in an arguably nicer format. Workflow execution started, then the task was scheduled, the task started, the task was completed, and then the workflow itself completed. Here's what it returned. So this is the sort of complete history view. There's also a compact view, which won't really make sense for such a simple workflow, but if we have multiple activities, it's basically showing each activity. And then there's a JSON view, and so we can actually download this, and in development, we could replay the workflow in a debugger. So if we encounter some sort of problem in production, we could recreate that on our development machine by taking the actual execution. So, I mean, this is amazing to me in terms of developer productivity that I don't have to guess like what took place in production. I can actually reenact it.
What about sensitive values or even PII that
Yep.
could need to be de-identified completely? Like if let's say we wanted to use Temporal Cloud, but we needed to pass like really sensitive information.
Yeah. So that's a great question. So you can see that it's taking your input and your output, it's saving that into the workflow execution event history. And if you have activities, it's also keeping track of the input and output of every activity. So what if that contained a credit card number, social security number, whatever, some sort of personally identifiable or confidential information. There is in Temporal, there's an API that's called data encoder. And a data encoder can be used to transform data that's coming out of a Temporal client and coming back into a Temporal client. And remember, the Temporal client is on the application side of things, and that is separate from the Temporal cluster or Temporal cloud. So you can create your own data encoder. It could actually do whatever you want. It could like translate, the input and output to Chinese if it wanted, but what it's typically used for is encryption. And so you can encrypt the data as it's coming out of the client, so that even though it does have to store the information for Temporal to work, it's encrypted, and this Temporal server or Temporal cloud can't read any of it, and it can decrypt it on the way back in.
So if you already have a DLP solution for the identification, you could just hook it up.
Yeah, your data encoder, it basically, it takes input and it returns output, and you can do whatever transformation you want inside of that, and it can use any business logic that you like, and then that's it. You can think of it like a servlet filter, if you're familiar with that in Java world. You can do whatever processing you need to do. I had to reach back for that. But it's that same sort of interface. You get input and you return some output, and you can do whatever transformation you need, and that can call out to whatever libraries or tools you might be using. The other thing I'll mention, just on the topic of security, it also has support for an authorizer. By default, the authorizer that's built into Temporal, particularly if you're using it in Docker Compose, it authorizes all calls. Like you're like, I want to start a workflow. Okay. I want to terminate a workflow. Okay. I want to read the data that's in there. Okay. But you can specify a custom authorizer to say these person with this certificate can do these calls. The person with this certificate can't do these calls. You can set all that up. Also, the communication that takes place, it's gRPC, but it supports TLS, and not only TLS, but mutually authenticated TLS. So it's a secure connection between the client and the temporal server. And if you're doing a self-hosted cluster, in a real sort of production environment, you're going to have probably multiple physical servers, and you want the communication between those to be secure, particularly in a data center environment where maybe you're co-located with a bunch of people that you don't necessarily trust. And so the internode communication can also use TLS. Yeah, so you get the TLS will obviously provide confidentiality for data in motion, and the data encoder is also for data in motion, but particularly important to data at rest because this is what gets serialized. Okay, so are we running out of time here? I feel like I'm going long. I was gonna. Yeah. Can I do one other demo?
Yeah.
It'll take less than 5 minutes. Okay. So this is a slightly more exciting demo in the Hello World, although it is still Hello World. And this is the Hello workflow. And so the worker here, so this is basically I talked about activities, and we're going to use a microservice to do the translation to Spanish. This is that. So if we look at the worker very similar to what you saw before, we have, oh, I didn't change directories after all. Okay. So we look at the worker. This is similar to what you saw before. Now we have an activity that's going to call out to greet in Spanish. So the workflow is greet someone. The activity is greet in Spanish. Otherwise, it's similar to what you saw before. So let's look at the workflow. We define the options with a timeout for how long before we decide that the worker is dead. We have the execute activity call, greet in Spanish. So this is exactly what I showed you before. Now let's look at the activity, which is in a file called translate.go. And so greet in Spanish, it takes a name as input and it returns the translation, and then potentially an error if things go wrong. It's the same code that I showed you before, so it's just doing an HTTP call. And I have a microservice that I wrote in Go that it listens on port 9999, and it's at this endpoint, and it's looking for a parameter called name. You pass in the value, and it says hola, whatever name you passed in. So pretty straightforward. But let's run this without the microservice. And I will first start up the worker. Now I will start the starter. Oh, I should show the starter code. So you asked Jessica, how do you start in the real world? How do you start a temporal workflow? I said you could do it through code, or you could do it through TCTL. I showed TCTL before.
You're just
but
using
here's
the client.
yeah, exactly.
So this is the client, but not the worker.
Exactly. So I create a client, and then I specify the ID and the task queue, same things that I did in the TCTL command, and then I say execute workflow, and I pass in the options and the name
So your workers are going to have both the clients and the worker library, but here you have only the client library.
Exactly. That's exactly right. So I'm going to run this, and then it's looking for me to specify something on the command line is the input, and so I'll say come, and then probably help if I say go run. Okay, so this is starting the workflow. You can see that the execution has begun. I've got a run ID. The worker's running over here. Close this unnecessary terminal window. The worker's over here, and
so it's failing.
Yeah, it's failing. So let's go check this out. So we can see the status is running. So I click there, and then first of all, pending activities up at the top. So there's an activity running, but it's not actually getting anywhere. Right here, I can see the last failure, and it should be obvious at this point, like what's gone wrong, just by looking at that it's a connection refused. And so I look down here, we've got workflow execution started, the workflow task started, all that's happening except workflow task scheduled. It hasn't gone any further than this. So we can see that the input Tom was passed in, but it doesn't have a result yet. And in fact, I can go over to stack trace over here and see a stack trace at any given time for this running application. I can look through here, know exactly what went wrong. And so I will now go run microservice. Okay, so I'm going to run the microservice. So what's going to happen is this activity is retrying according to that policy. 1 second, 2 seconds, 4 seconds, and so on, all the way up to the maximum interval of, this is the max way of annoying me about starting up a socket on port 9099. So the microservice is now running, so the next retry of this activity should succeed. I don't have to do anything, I don't have to restart anything, it's just all these other invocations failed. And so if I go back here, I can see where it says attempt right there. It attempted 7 times to call this microservice. It was unavailable 7 times. And so if I wait for, it tells me the next retry is going to be in 1.924 seconds from now. So presumably it's automatically, it's already happened. I asked our awesome web UI team, our front end people who are just so incredible. I asked not long ago, I was like, wouldn't it be great if the page automatically refreshed and like 2 days later? I'm like, okay, there we go, automatically refresh. So this page will automatically refresh. Instead of, it does it, I think, every 15 seconds or something. In the interest of time, I'm just going to manually refresh that page. And now you'll see that this is complete. So we got through workflow tasks completed, and now we're all the way up to workflow execution completed. So if we click input and results, we can see Tom and then hola Tom. So it executed the activity which called out to the microservice and got the result back. And there we go.
So if your company, if you were about translating into Spanish, if that's like what you did, then you probably would have made that a workflow. Like your greeting workflow would call a greet in Spanish workflow and use the return value.
That's a reasonable thing to do.
Because
Yeah.
then it would be tracked.
Yeah.
Because I mean the any code that you put into a workflow has all the overhead of its state saved, of the history being forever, of compressing all of time into to be available every minute, which I mean the universe doesn't do that for reasons. But if this is like what your company does, if you are about orchestrating chicken orders and tacos and pizza, then you want that record. You want to be able to look at it and see what's happening. But if the translation service, if you're calling out to another company and you're just we just want that to work, that's not our crown jewels, then you would make it an activity.
Yeah, that sounds reasonable to me.
Is there I see you have the web UI. Does it like output telemetry? Say like some open telemetry so you could open up to tracing?
I don't know if it uses open telemetry specifically, but it can generate metrics, and it uses Prometheus. I mean, Prometheus is commonly used. It doesn't dictate the use of Prometheus. Presumably, you could do it. Maybe it does it with open telemetry. I'm not sure.
No, open telemetry will read Prometheus endpoints.
There you go. But people use Grafana dashboards and to keep track of their application metrics. It's very common.
Yeah, but you could definitely create traces from this.
Absolutely, and even
it's like right there.
Yeah, even the Docker Compose. I showed the Docker Compose. Git clone Docker Compose. So we provide a Docker Compose repository, but there's a bunch of different variations in that Docker Compose. I'll just open here. But there's a whole bunch of different configurations. So there's ones in there with MySQL, Postgres, and Cassandra, and TLS, and so forth. My colleague Tiho Sergolovic, who's on our support team, he has created one that's like out of the box. It's got Prometheus and Grafana. It's already set up, and so even in a development environment, you can just use Docker Compose. Just boom, it's just done. So, and there's documentation on how to do it for production systems as well. Okay, so that's that brings me. Hold on. Wait for it. The end.
Yeah.
All right. Any questions? Any further questions?
Yeah, kind of wondering. So with some of the workflow, does it have like branching, forking processes, so you can have a workflow that branches into multiple things, and then a collection point?
Yeah, so that's a great question, and I've worked with other workflow systems in the past that have that sort of fork and join.
Yeah.
And so I wondered when I started, I was like, does it support that? And I never saw it anywhere. And finally asked somebody about it, and the answer I got was, I mean, it's code. You can do whatever you want to do.
Yeah.
So
Yes, go. Make
Yeah.
a channel,
Yeah.
follow workflow on every channel.
yeah, exactly. You can do whatever you need to. It's just
Mhm.
code. So it doesn't need to have all these special cases, because what you can do in code, provided you don't violate the determinism,
Right.
rule, you can do whatever you need to.
For the databases backend, do you have any plans to support more, which distributed databases you support? I heard Cassandra. I think that's.
Yeah, Cassandra.
And I've been reading lately about CockroachDB. You have.
Yeah, I don't think we actually. So, like, what do we support? We support Temporal itself. We don't support databases per se, but we test with MySQL and Cassandra and Postgres. There are people that are using it with other databases, like for development. You might use SQLite, and I know that works. I think there may be some limitations, but it definitely works. There are other people that are using other databases, and I feel like CockroachDB may actually be one of the ones that I've heard of other people using.
It was in the
But-
Docker Compose list, right? When you did the LS
Was it?
chapter.
Oh yeah, there you go. Okay, yeah. So the Docker Compose is generally meant for like development use. So maybe like it does work, and this is how you could use it. Do we support it? No. CockroachDB supports CockroachDB. I don't think we test compatibility with it, but there are definitely people using it, and that's generally true of any database. What I understand is like any database that supports transactions and does it in a ANSI SQL compliant way should work, but we only test with a certain set of them. And we encounter bugs. I remember reading the documentation recently, like MySQL, like 8 works, but not 8.0.15 or something. Like we found a bug. It doesn't work with that. And so we specifically call out the documentation. You can use 8.0.16. Yeah. All right. That's it. Okay, yeah, thanks a lot. Appreciate you coming out.
Yeah. I'll just switch over
Yeah,
to
thanks for
that.
doing the talk. And it will be
Oops.
online.
Yes.
Oh,
Let's see,
and
three,
I should also
four,
mention
two.
one last thing. I didn't, maybe I think I stopped sharing my screen, but I can at least show it still on the screen. If you go to temporal.io, first of all, because we are very much a developer-centric company, like the link to GitHub is right up there, right at the top. And so if you back up, this is the Temporal server source code. But over here, if you type in samples, there's tons of repositories. There's repositories for each of our SDKs. So there's a Go samples, TypeScript, Python, and so on. But if you go into Go, for example, like here's choice workflow, choice exclusive, choice multi, like, different sort of scenarios. Hello world with TLS, interceptors, file processing, and encryption, how to do a data encoder, all that kind of stuff. It's all there. There's all descriptions of what all those things do, so you can try those out. And then finally, there's the documentation, docs there. Learn that's the part I'm involved in. So there's tutorials, there's a training class, Temporal 101, that is much like what I showed you. It goes into a lot more depth about things. Totally free. You can sign up and go through it and try everything out for yourself if you want to learn more. And that's it. So thanks a lot.
Sweet.
And if you want to see what companies are using it, There's some
Logos.
there. There's a whole lot more that I can't name, but it's a handful of things you've heard of. Okay.
Let's see if I can
I will
grab
stop
this
it.
thing back. Oops. Let's see. Oh, wait, why is this?
Very interesting, thank you.
Yeah, thanks a lot.
Yeah, it's funny the functional programming concepts just crop up everywhere.
Yeah.
Which code can you predict? Which code can you really track? Which code is just gonna do things in the world? And all you can do is try it again. Those distinctions keep coming up.
Yeah, so much of the stuff that I learned at the Lambda Lounge, 12 years ago or whatever, it all is like, this is coming in handy. Like, I'm glad I paid attention because there's so many concepts that like just come back to me.
Totally.
All
So
right.
these posters,
Yes, please do grab one. Yeah, those are from the what you call it, the birthday from the 10-year. So those were pre-COVID, right there, pre-COVID. But yeah, and then let's see, I'm gonna.
I have a colleague that was
Yeah.
telling me that he really wanted to learn Go, and now I want to learn Go.
Yeah.
So, but yeah, this at least in my mind, it seems like a good way. I can't remember. Well, I can't think of a good use case, but to make or to design a very polyglot system.
Oh, I forgot to mention that. Yeah, so you can have a workflow written in Go and an activity written in Python and a different activity written in Java. And there are examples in the repository that I showed you. There's a polyglot example. There's a couple of them, but there's one that's actually called polyglot.
the temporal libraries are doing the gRPC?
Yep.
Oh, great. So I'm up
Oh,
next
yeah.
month. Should we have a meeting next month? Because December's usually like a bunch of students take off.
I mean, we can postpone it for January. I mean, I'm good with that. So. Let's make it January.
I'm gonna be
Somewhere in the
gone.
middle of January, and then yeah, I'll send out the info, and then yeah, so cool. Thanks everybody.